Thank you all for being here today. So before we jump into everything, I want to get to know you a little bit. So raise your hand if you are a denturist. Yes, one denturist, two denturists, woo! Raise your hand if you're a lab technician. Lab technicians? Yes, you are my people. Raise your hand if you are a removables lab technician. Keep them up, high, 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 high. I want everyone to look around the room. These people, you can put your hands down, thank you. The removable lab technicians are your future most valuable technicians. And I want you to understand that the value that you have as a removables lab technician is absolutely insane. I don't think we've ever really been considered the most valuable in the lab before, but I'm a removables lab technician, and I want you to know moving forward, especially with the development of AI, with the development of CAD CAM, with all of these new systems, your knowledge of the full restoration of a mouth is invaluable. And this can be put into zirconia full arch case designs. You don't need to know how to output zirconia. I'm not a zirconia tech, but I know how to set up those teeth to make a full mouth restoration. So I really, really want you to understand the value and the power that you have in industry. And if you here are a lab owner or you're looking to get into hiring lab staff, keeping a person with a removables background is so invaluable to your clinic, your lab, whatever you want to do. We have so much knowledge, and I just want you guys to know the power of what you have. So that's not even what we're talking about today. I'll stop being sappy and we can jump right into what we're actually talking about. Just know I love you. We're a good community. We don't have to be tucked in the back corner anymore. We're finally here to show our knowledge and our presence and our power in what we're doing. So let's be proud of what we're doing and let's build something together. So what are we going to talk about today? Not that, but similar. Let's get into what we're talking about today. So, a quick overview. We're going to talk about digital dentures. And I think sometimes when we get into this, we start talking about what equipment are we going to use. That is the wrong way to approach this. That is the last step that you want to get to. So I put this in a very specific order because I want this to kind of be your way of thinking into getting into digital dentures. So, first thing we're going to do, we're going to talk about our manufacturing options. You need to know what your end output is, how you get there, and what that looks like before you can decide what equipment you want to purchase. We're going to talk about some practical workflows, so ways that you can work with your clinicians, with your dentist, and we're going to really make sure we can tie all of that together. We're going to maximize efficiency. Efficiency is where our money is. And then we're going to get into some equipment options. Equipment options should be the last thing you're thinking about. You really need to plan this out, or you're going to get burned. And and as the people who are kind of pushing this and starting this, we've all been burned. We bought equipment that doesn't work because we didn't really fully understand what our output was, what our goals were, and what's going to work the best for us, right? So let's break down these categories a little bit here. Let's talk about our manufacturing options. So, in dentures, we all know we have two primary options. We can print them or we can mill them. So that's kind of the two ways that you can get there. There are obviously some hybrid workflows where you can still incorporate digital, but then end up with a result that is an analog process denture. I'm not really going to touch on those today, but if that's something that you want to just start introducing into your lab, get a little bit of digital, but still have an analog end process, totally doable. I'm not going to really talk about that today. Come talk to me afterwards. I love talking dentures. We'll talk all night. So, within the printing and milling, your two options, there's three main manufacturing workflows, three main outputs. You need to know the value of each, what they can bring to you, and why you would decide to use those. So the first one that I will say is a milled base with carded teeth. So I'm going to go through kind of the industry pros and cons. What I have heard from industry, and I'm going to talk a little bit about my thoughts on that. So industry pros and cons for milled base. Pros, great aesthetics. These are the same carded teeth that we have been using for 50 years. And so these are the carded teeth that our dentists are used to, right? So if you have dentists that don't necessarily want to make the transition, they don't even necessarily need to know that you're digital because you can still have a milled base with the exact same carded teeth, the same aesthetics, same everything that they're used to. So this is a really good way to keep your aesthetics the same. These are known materials, so even the pucks that you're milling out of, it's the same as your Ivoclar, it's the same as your Lucitone, whatever you're using, it's just been compressed into a puck. And it's actually probably better than what you're using because it's been compressed at much higher density than what we can do with our small equipment, right? So these are known materials. This isn't a new material, so I really like these workflows for that. It's a milled tissue fitting surface. I will get a little bit more into milling and how we can really get a better tissue fitting surface than we could ever achieve analog. So I'll talk about that a little bit. And it's easy to manufacture. So it's really important if you're growing a new segment of your business or you're trying to grow into a removables, you need to consider your labor. And how easy is this to train? And where are your most valuable assets? We are a shrinking breed. We are a dying breed, us removable technicians. Hopefully we can get more people in here. So you are most valuable designing and planning cases. And so you want to bring in, I hate the word unskilled labor. So from here on, I'm not gonna say unskilled labor, I'm gonna say lab assistant. So you wanna bring on your lab assistants to do the manufacturing. And the two key words that I'm gonna say over and over and over today is consistency and efficiency. You need consistent results and they need to be efficient. So why are we putting our most valuable staff on the processing line? They should be designing, they should be case planning, they should be interacting with your dentist. So this is a very easy manufacturing, and we'll get into a little bit into manufacturing in a minute, but this is very valuable for your lab assistants to be doing these work. So we'll talk about that. The cons, the industry cons, so bonding individual teeth. Honestly, this is more of a personal qualm. I hate the idea of bonding an individual tooth. I think it's a little time consuming, not as efficient. There is a little bit of room for human error. If you put too much material or it's not seated all the way, it could potentially affect your bite. Less design options. So once you start getting into digital as a removables tech, and you have the freedom to morph and change and adapt your teeth, you're never gonna wanna go back to a carded tooth ever again. You have the freedom to design it exactly how you want, exactly how you need, and going back to a structured, rigid, carded tooth is so painful. So you don't have as much design options. This is still a really good way to produce your digital dentures though. And then lastly, sometimes a single arch. If you need to cut those occlusal surfaces of the teeth, there are ways to do that. You can make a little jig and anything that sticks out, you can cut it down. Again, consistency and efficiency. Can we consistently get an accurate bite by having someone manually grind in the bite? Probably not. The results are gonna vary a little bit. And then again, what kind of labor is involved in that? Do we need a highly skilled person to make sure that this is going out the door with the quality that we want? Or can we put that person into a more productive role? So the second option is a milled base with milled teeth. Pros, and this is kind of coming from industry and my thoughts on it. So a milled tissue fitting surface, again, we're gonna talk about that a little bit later, the quality of the tissue fitting surface that you can achieve by milling a denture. Bite is accurately milled in. So instead of having to change your occlusion by hand with a jig, the mill's doing that for you. So you can make a lot of adjustments to the occlusal of these teeth, especially if you have like a single arch, a natural single arch. You can really make it look nice because you can actually add material and take away material. Whereas in analog, you can only take away, you can't add. So we have a lot of tools at our disposal, but we need to be able to mill those out accurately. So the bite is gonna be super accurately milled in. You're gonna have a much stronger bond because you have a full bridge of teeth, not individual teeth. You're never gonna have a tooth pop because they're all stuck together and then they're all bonded in there together, right? So you're not gonna have any issues with tooth popping. And again, these are known materials, just like I said. And again, we have more tooth design options, just like I said. So some of the industry cons that I've been faced with is tooth aesthetics. I think maybe when I started in digital dentures about 4 years ago, tooth aesthetics was a concern. The materials have changed so much. The way we approach this has changed so much. And I think we're still giving our patients a better product in the end. And me, as a technician, I can obviously see the slight difference between a carded tooth and a milled tooth. My patients, for the most part, cannot. And if they are super high they really, really want that high aesthetics, maybe they're willing to pay for a zirconia case. Maybe that's when you bring in your carded teeth. But I would say 99% of your patients are gonna be so much happier with the function and the fit that the slight difference in aesthetics, which honestly at this point in time is very minimal. You can get these dentures to look amazing now. We have better materials, we have better techniques than we did 4 years ago. So I think that argument is kind of moot now, but let's have a discussion later. Come talk to me. Milling time. So this is also a big discussion. And I think if you're coming from a crown and bridge background, it's so painful to think about milling a denture because in the time you can mill one denture base, you can probably mill 3 pucks of zirconia like packed to the brim with crowns, and you can get a much bigger output. But I think we need to change the way we're looking at this. This is a different product, a different workflow. We can't compare these two things. So I would suggest if you want to get into this, you have a dedicated mill for PMMA, and you can't think about it in those terms, but we're going to talk a little bit more about efficiency in a minute here. And then undercuts. This is the biggest argument. This is probably the #1 reason I have people saying, milling is not there yet, milling is not there yet. And I have milled dentures for about 3.5, 4 years. I was working with a denturist. We were milling dentures. And even about 4 years ago, I might have agreed with you. It's not a hardware issue, it's a software issue. The mill has the capability to mill these undercuts. I would say 95% of my cases, the undercuts were fine. The 5% that weren't, those undercuts were so extreme, I'm not putting that in my patient's mouth. I'm gonna adjust that anyways. I'm gonna block that out anyways. With a 5-axis mill with the right milling strategies, that's the key, having a mill that has the correct milling strategies to access those undercuts. It's totally doable. And there's actually a denturist in Canada who he teaches suction, like the SMCD dentures, the fit of his denture, like top quality. His impressions, like you could drool, they're amazing. And he switched to digital last year, and I went out and trained him, and I really respect his work, and I asked him his honest feedback, give it to me as honest as you can. So I came back in 6 months, and I said, well, how is the fit of your dentures? Because you are so particular about the undercuts, the way it fits. And he said, I would never go back to analog, ever. Every single case, this fit is bang on, and I can put it right in the mouth. So I don't agree with the argument that you can't get these undercuts. The undercuts that you can't get, you're not putting in the mouth. This is just a personal qualm. It's a subtractive manufacturing process. So in that sense, if you don't like waste or you care about the environment, you shouldn't be in this industry. It's painful, so I understand it's a subtractive, you have a lot of waste, I get that. It's something we have to deal with. We also have a lot of waste when we're doing analog processes too. It's painful, but this really is a good product, so there are pros and cons that you need to weigh and decide where your maximum value is, right? So this is the last option here, which is a fully printed denture. And I'm going to dive in a little bit into printed dentures right now, and then I'm going to talk about milling kind of as we go along. So for a 3D printed denture, the pros, obviously the biggest one is a cost saving. It's so cheap to print a 3D printed denture. It's an additive manufacturing process. There's way less waste. I get that. It's very time efficient. And I think that's kind of the industry questions is it time efficient? And when I came into this, I thought, oh yeah, I could print a denture way faster than I can mill a denture. But what I wasn't considering was the post-processing time. And I think we really need to pay attention to that also. So what is your post-processing time, and how does that add to the full time? So I'm gonna talk about post-processing here. We'll go a little bit in depth in printing. So some of the cons, denture strength. For me, this used to be a big con. In my head, I was like, the strength is not there. I've kind of changed my thinking a little bit. I don't think that is the main con that we need to be focusing on. I think the strength is there. I think for a lot of these materials, we have that strength. I don't think that's where the issues lie. I don't think that's where we should be focusing our attention. We have really good resins out there right now that totally meet that 5-year turnover mark. The long-term use is unknown. We have been putting this in patients' mouth let's say generously 7 years, maybe, probably more like 4 to 5 years. And even then, how many have we actually put into the patient's mouth? We don't really know the long-term usage of these in the mouth, not like the wear patterns, but more how it affects the patients and that kind of thing. These are new materials, so we don't really know the longevity of them fully just yet. Denture aesthetics, same as milled. I'm not going to have this argument. Some people like high aesthetics, some people like low. If this is a con for you, you need to determine what values for you, for your lab, for your clinic. So for some people it's a con, for some people it doesn't really matter. And then printing sprue location, this is interesting. Depending on what material you have, depending on the instructions, where do you put those supports for your final denture? Do you put them on the occlusal surface? Is that going to affect your bite? Do you put them on the tissue side? Is that going to affect the fit? So some things to consider. Every material has a different way that you're supposed to support it. I would look into that before you really invest in a material, how they sprue, how they get supported, what that looks like when it's finished. This is more of a complex manufacturing. I'm going to break that down in a sec. We're going to kind of look into why. But this patient aftercare is also a really big thing. The way that you care for these dentures afterwards is different than how you would care for a milled denture. And we need to be knowledgeable of that, and we need to teach our dentists, who then need to teach their patients. And this is not something that I had really considered or understood fully until more recently, because in my lab we were doing milled dentures. We only did printed try-ins, so it just wasn't on my radar. And I'll talk a little bit about that when I talk about IFUs, but it's also something we have to change the way patients understand to care for their dentures. That's hard. If Martha has a denture and Margaret has a denture, they don't know printed versus milled. They don't know, like, oh, my dentist told me never to soak it. My dentist told me to always soak it. Oh, well, you should do what mine said. Like, it's so ingrained in people with dentures to soak your dentures overnight. With printed dentures, you can't soak them overnight. The rate of sorption, and thank you very much to my smart friends for teaching me what sorption is. In simplified terms, it's essentially how much water is being absorbed into the material. That's a very simplified version of what I'm talking about. So for a milled denture, you can soak it and there's not that much water being absorbed and affecting the chemical properties of these resins. For a resin denture, it's not going to happen overnight, but over the period of a couple months, over a year, your denture will start to warp because it's absorbing water and changing the properties of the actual resin. So you can't soak them overnight, but that leads to other problems. So if you can't soak them overnight, typically when you're soaking your denture overnight, you're soaking that calculus, and in the morning you can brush it off. It's nice and soft. You can clean it, get a nice clean denture. If you have to leave your denture out overnight and you don't brush it before you go to bed, in the morning that calculus will start to get hard. And these are already a little bit more of a porous material. So I don't think the cons are hardness or strength. I think it's patient aftercare and figuring out how we can get them a denture that's going to stay clean and going to stay with the structural integrity that we made it for 5 years. 5 years is in Canada, that's kind of our insurance turnover. I just need a product that's going to last 5 years, and then I can get them back for a turnover, right? Yes? Well, there are both. So there are people using printed for permanent dentures. I personally would use it for a temporary, but there are plenty of people doing it for permanent. I think that you just need to understand the properties of what you're providing to provide it as a permanent denture and really educate your dentist. I'm just going to take a sip of water. So I'm going to go through a video real quick. And I stole it directly from the Asiga website. This is not my video. It's right off of Asiga. If you want to watch this video or save it for later, this is the little QR code, so you can scan that on your phone, and it goes right to all of their workflows for their specific resins. I'll leave that up there for a second. So when I say complex manufacturing, what I'm talking about is the process after the printing. The printing's easy. Put it in the printer and you print it. In America, the resin is not approved. The process for the resin is approved. So you have to make sure you're following the steps, and that's how you're getting an approved product that is safe for use. It's not the actual resin, it's the whole process. And these have been tested and approved on specific printers with specific wash times, with specific cure times, in specific cure units. And that doesn't mean that there's only one thing that you can use. A lot of these have been approved on multiple printers, multiple cure units, but they all have a specific set of instructions to get you to this final point. Following this instructions, the instructions for use, the IFU, is the only way that you're going to get the same product that you see at the trade show today. You're going to walk around this trade show, and they're going to tell you, we did studies, it's this hard, it can withstand this, it's good at this, only if you follow the exact steps for post-processing. And to get the consistency in an efficient manner, you need to follow the same steps. This was not explained to me when I started printing. I got a printer, I got training on how to make a print, and I didn't even know what an IFU was. Luckily, I was only printing try-ins, but still, the health and safety of my patients, even though I'm a lab tech, that should be my #1 concern. I don't want to be putting things in patients' mouths. I don't want to, 5 years from now, see a commercial that says, "Did your dentist give you a printed denture? You can now get insurance," or whatever, right? So I don't want to see that in 5 years. I want to make sure that my product that I'm delivering is safe. So I need to follow the IFU. And I'll be honest, I wasn't. And it didn't really click until recently, till somebody really brought it to the front of my attention. And I was like, it's so obvious. It's here, it's in my head, it's obvious, but I wasn't thinking about it in that sense, right? So this is just a really quick video. Like I said, it's directly off the Asigo website. There's no sound. We're just going to walk through it so you can kind of see what one product might look like in your lab. So if you haven't seen a resin printer, this is just an Asigo printer. You don't have to use this printer, but one example of what it might look like. And this is quick. It's only a couple of minutes, but we'll walk through it. So on the bottom there, you can see all the resin, and it's going to cure it to the plate. So you can see the build plate is going to go up and down, and your denture is going to be cured to that plate. This specific one here, they put the sprues right on the bottom. You can't do that with every resin. Every resin has different properties and rules for support. So I'm not sure what they're using here. It's probably an Asigo resin. That's my assumption, but that's not the focus here. So once you printed it, then you're going to come here, and he's going to take it off of the build plate, and it's going to look really cool. Again, not my video. Can't take credit, but I thought it was really good for us to kind of go over everything. So the first thing you're going to do is wash it. And some resins, you cannot wash them with just an ultrasonic. You have to read what the instructions are. Some of them you actually need an agitator so that they spin around, and it actually says that in the IFU. You can't use just a standard ultrasonic like this guy. You have to actually use an agitator. So he does a dirty wash. I think it's at 5 minutes. And then he takes it out, and he does a clean wash. The other thing is, if you are printing multiple types of material, you can't use the same isopropyl alcohol for all those types of materials. You have to have different containers for each one. If they're going in the mouth, you don't want to mix materials together, right? So you can't be even washing them in the same container. If it's a model or something that's not going in the mouth, that's totally fine. It doesn't matter. But if it's going in the mouth, you have to have a separate cleaning one for each one. So they're going to clean it, and then it says here, make sure you dry your parts for 30 minutes. I never did that. Make sure you dry your parts for 30 minutes. And this is to ensure you have that same quality that they're telling you can get out of this. You can't get that unless you follow these steps. So now he's going to print the teeth. I sped up the video. It's super fast. We don't have to watch all that really slow. And he's printing the teeth, and then we're going to do the exact same thing. So he's going to take it off, and I'll just skip ahead a little bit. He's going to do the exact same thing, washing it clean, washing it dirty. Once you print it, you have to put it in the auto flash. Like, you have to rinse it, you have to let it dry for 30 minutes, you have to put it in your auto flash. You have to, or any flash, it has to be an approved cure light. So the auto flash is probably the most common at the moment, and it's approved for a lot of different resins. And you have to cure it at a certain amount of time. So this one, this specific one in their video, they cure it for 2,000 flashes, and then it has to rest for 5 minutes because it gets really hot. So if you keep curing and curing and curing, you have the potential of warping it. So it has to cure for 5 minutes, rest for 5 minutes, cure again for 5 minutes, you flip it, you cure again, rest for 5 minutes. And I don't remember how many times they do that in this video, but you have to do it a couple of times. And then for this specific resin, you're supposed to actually soak it in fresh tap water for 60 minutes. before you insert it in the patient's mouth. That doesn't mean moving forward, you have to soak it, but before you can insert this in the patient's mouth, you're supposed to soak it for 60 minutes. So now, let's say we printed our denture in an hour and a half, much faster than we can mill it. We have now added an extra almost 2 hours of post-processing onto this, right? So we need to fully understand before we purchase a printer, before we decide what we're actually outputting, which resins are we going to use, and what is their post-processing process? What does the time look like for that? On a labor side of things, is this something that has a lot of human error? Is this something I can trust my staff to do, follow these steps exactly? Do I need to put signs in place? Do I need to put labels in place? These are all things you need to consider before you even buy your equipment. All these printers have different resins. All these resins have different rules. And I recently went to a convention in Canada for denturists, and there was a denturist there who really did a deep dive into this, and like, it just clicked. And I honestly hadn't even looked at the IFU for some of these resins that I was telling people to use. I had never personally used them, but I feel if I'm going to suggest you a resin, if any of you suggest any of your peers a resin, it's your responsibility, it's my responsibility to emphasize this resin's great, but you need to do all these steps to get to that point. We are taking shortcuts already, and we just jumped into digital, and we're already trying to take shortcuts. And I think with a product like this, it can be really dangerous to our end users to take shortcuts and to not cure those resins properly or not give our patients the quality that they deserve, right? So sorry about the video. If you had the little QR code, you can jump right ahead. So this was my colleague at the Kelowna show, and I asked her permission if I could just steal her slides, and she was like, it's all on the internet. I was like, I know, but this is easier. So she's great. She gave me her slides, and like she said, it is all on the internet, but the way that she laid it out was really nice. So I got them from her. Her name's Tanya. She's a denturist in Canada. Really great, does a lot of printing. And what she said, the way she explained it, just instantly changed my thinking about this. So I wanted to share that with you. So I asked her permission, and she was happy to share. So these are just 3 examples of 3 resins and kind of what they look like, and things that I wasn't necessarily paying attention to. So for example, it's a little cut off on the side there, but for example, oh yeah, nice. If you look at the mixing time for Flexera, it's 12 hours. You're supposed to mix this resin for 12 hours before you actually use it. I didn't know that because I never read the IFU. And so I'm telling you to read the IFU. Before you decide, I'm going to buy an Einstein printer specifically for Flexera, or I'm going to buy a Sprint Ray printer specifically for this resin, ask the questions, what is the actual full processing time? How do I use this resin? Read the IFU before you invest. This is still an excellent product. You can still get a very good denture out of this. You just have to know you have to mix your resin for 12 hours before you use it to get the same level of quality that they're showing you at the show today. There's just a couple more. I just took 3 of them. So here's another one, the DTEX denture base. Again, you should be shaking it for 5 minutes and rolling it for 2 hours. So if it says rolling it for 2 hours, that's an additional piece of equipment you need to purchase to roll your denture resins. And honestly, some people just use a hot dog roller. You don't need like a fancy roll thing. Just get a hot dog roller, roll your resin, it's good. But also like things like the drip time. So when it's finished printing, you don't want to take it right off the platform. You should let it drip for 10 minutes. And these are all things, they're all written out. They're all on the internet. They're for public access. They're just not being pushed in our faces, which they should be. So I'm pushing it in your face today. And then the last one here, just a Dentka base. So same thing. You should be shaking it intensely with a bottle roller before using it. I never did that when I used this material, and I'm ashamed to say that. I never did a final output. I never outputted anything final in patients' mouths, just immediates and try-ins, but still, I look back and I reflect, and I feel like I completely missed the ball on this. So I want you guys to just understand this before you jump into manufacturing. Yes?
What do they mean by the drip time?
The drip time is, so once you print it, it has to sit in the printer and let all the excess resin drip. And this is just for maximum performance of your thing. So you don't want too much extra resin in your wash. And so every resin has a different viscosity. So to make sure that your wash doesn't get too dirty, you have to let them drip for different amount of times. So that's all available on the internet. And So what we talked about now is our manufacturing options. So we know how to manufacture, we know what that looks like before we purchase equipment. So I want to get into some practical workflows, maximizing our efficiency and some equipment options. So let's talk really quick about an analog workflow so we're all on the same page, so we're all on the same understanding. We all know what this looks like. You do your prelims, you do a custom tray, you do a wax rim, and a wax try-in. This wax rim is actually a custom tray and a wax rim all at one. So you can kind of put that into one appointment if you wanted to. And then you do your finish. Obviously, there's going to be a lot of try-ins in there, and there's some other steps, but these are the basic steps for an analog denture, correct? We're all on the same page. How much time is it going to take us to make a denture? How much hands-on time are we using to make a denture? So this is obviously going to vary depending on who you are, blah, blah, blah. So let's go through this so I can explain kind of where I'm coming from. White is how much hands-on time. Gray is how much processing time. So let's break it down. We're pouring our preliminaries. 5 minutes to pour it, 15 minutes to sit. Tray and bite rim. So when I say a case, I mean one upper, one lower. So moving forward, anytime I say one case, 2 arches. A full upper-lower denture is one case. So for one case, 35 minutes to make your Ivoline base and your wax rims all in one. We're compressing this into one appointment, all in one, 35 minutes. Then you're going to take your finals. They're going to come back. You're going to pour your finals. Maybe. There we go. 10 minutes to pour your finals, 20 minutes to let it sit. When I focus on the lab side, we are on the ball. We have no issues. We're fast. We know what we're doing. We're efficient. So that's kind of the timing that I put in here. We know what we're doing. We're experts at what we do. So we're going to mount this. 5 minutes to mount it. 15 minutes to let that set, 10 minutes to make your new bases for your final, so you gotta block out your model, make your little bases, so you can make your final denture, or if you did the tray and rim, sometimes you can use the old one, but I put this in there, 10 minutes. 10 minutes to let that set and wax teeth. An upper and a lower, completely set it, completely wax it, we're on the ball, we know what we're doing, 90 minutes. Some of you can probably do it faster, some of you might take longer. I'd say 90 minutes is about an average for one case to set and wax. Once it goes to the patient, they love it, no changes. We're just gonna adjust it a little bit for finish. So we're gonna wax it to the base. We're gonna check our contact because it's in wax, and if we left it overnight or if we shipped it on a car or something, our contacts might change. So we're gonna check our contacts, re-wax the whole thing, check your contacts again, fix your wax up, a little bit of back and forth. So 30 minutes for your upper lower to adjust it, get it ready for investing. Then we're gonna invest it. I put about 40 minutes of hands-on time, so pouring all of your layers, doing your putty, however you want to do it, all of that stuff, boiling it out, everything there. So about 40 minutes of hands-on time, kind of an average, and about 20 minutes of setting time mixed into all of that. Then we're going to inject it or pack it. So separating, preparing your teeth, making sure they're all glued in, all of that. So we're going to inject it or pack it, and then 90 minutes to cook it. That also depends on what material you're using. I was using IvoCap, and you're supposed to technically cook it for 90 minutes. You can cut that back a little bit to push your time, but 90 minutes. Then it comes out, and we have to break it out. We have to repair if there's any stone stuck, if you have any acrylic bubbles, if you have stone on the underside, if you crack something. So allowing yourself time to repair it. So break it out, repair anything you need to repair, fully trim it, fully polish it. I said about an hour for an upper and a lower. I'm sure we can do it faster, but I'd say that that's an average. So how much time are we spending? We're spending about 5 hours with our hands, and this is not considering batch processing. Like, you're very rarely just processing one denture at a time. So I understand that, but I wanted to use this as an example so we can kind of get a starting point as to what that looks like. And about 3-ish hours of background processing time. So how can we get a little bit more efficient in digital? Let's walk through what a 3-appointment workflow would look like. It's not just on the lab side. We need to be teaching our dentists clinically how they can cut their chair time back, and we need to work with them and explain to them what that actually means and looks like. What is each clinical step? What is their role? What is our role? We need to have a full understanding. We need to educate our dentists also. So 3 appointments, what does that look like? We'll break this down a little bit further, but we'll do a wash impression, a printed try-in, and a final insert. This is obviously not accounting for multiple try-ins, but this would be your basic workflow. So what does that mean? Appointment number 1, your wash impressions. This is not for every patient. This is selective. Some patients have really bad undercuts, or the flanges are cut really short, or it's just a terrible denture and you don't want to use that for like a custom tray. But a lot of patients don't. You can use this essentially as a custom tray, so you can take a wash impression on the first appointment. The second step is to scan it. We do not pour impressions anymore. Never pour a final impression ever again. We're scanning our final impressions. So this is a Trios. This video is sped up a little bit, but this is my first time ever using a Trios to scan a denture. I had a bench scanner, so I never had to use our Trios. It was only for intraoral. And I had a Trios, I had a demo unit a couple of weeks ago, and I'm like, yeah, I can scan a denture just as fast as anyone else. And I can't, and it was really bad. But even me, someone who has never used an intraoral scanner, this took me about 10, 15 minutes. You can definitely get that way shorter. But for your practitioners, or if you're a denturist, this is definitely, you don't have to get both an intraoral and a bench scanner. You can scan your dentures or your impressions in an intraoral. And this is the model that came out of that. This is the exact model from that specific scan. So you can see I did capture all of the information I needed to capture from that denture, and I made a really nice model. So if I had an impression in there, I could do the same thing. And then this is just an example of a bench scanner. Same thing, this is super sped up, but if you had a bench scanner, you'd throw it in there. This is an E4. The F8s are out now. They're super cool. There's probably one here somewhere. Go check them out. But this is an E4, and just showing kind of what it would look like in the software in 3Shape and what it looks like to scan a denture. The nice thing about this is it's a lot easier to use. It's a lot easier to train someone to scan on a bench scanner. It's a little bit quicker. So coming back to that thought of labor, this is a little bit easier to train on and a little bit quicker to use. Not saying that you have to get both right away or one or the other. You can start with one and then get into another one if you needed to, but I really like a bench scanner from the perspective of a labor side. This is easier to use and manage. And then we're going to design it. So when we're designing it, how can we reduce, so like I said, efficiency, consistency, how can we consistently get a much less amount of try-ins? Because I know we've had those cases where it's another try-in, another try-in, another try-in. And then finally at the end they go, well, their old dentures didn't look anything like this. And you're like, I have no reference of their old denture. How was I supposed to know when you don't actually communicate that to me, right? So now what we can do is have them scan a copy denture. We can have the reference of their old denture. This gives us so much power. We can set it exactly the same. We can make our changes. We can show the dentist why their old denture wasn't working, where we think the changes should be. We have so much data from this reference point. Another tool, we can actually put patients' photos right into 3Shape or a 3D head scan. There's not too many options right now for the actual scanners, but if you know someone who has one, you can also input a full 3D head scan. But you can put in a 2D frontal face, you can line it up. Now this is obviously not perfect, but it's an extra tool. We can use it as a guideline. This isn't going to give you super accurate results. Still do a try-in. Don't rely on this for your final dentures, but it's going to get us way closer to one try-in. So once we've designed it, then we have to print it. So this here is specific to that Asiga Denta Tri. So if that's something that you want to look at and you want to find the IFU specifically for the Asiga Tri, it's right here. And this is kind of what that looks like when you print it. So when you 3D print your try-ins, they're all one piece, they're all white. You can't just go digital and not tell your dentist, because if you send them this, they're going to be like, what is this? I don't know what to do now. I've literally heard stories of dentists saying, well, how do I use this? What do I do now? It's like, it's a try-in. Just put it in their mouth and try it in. Also, so you need to kind of educate your dentist before you just dive into this. Also, this Asiga in Canada is approved for 30 days in the mouth, which is really nice. You can send your patients home with this, and if they want to test it out, they want to show their spouse, if you want to see the function of it, so let's say you want to open their bite, and you don't really want to go to finals just yet, you want to see how they do with an open bite, crank it open and put them in a try-in and see what happens. Also, if they have a speech issue with their past denture, if you correct that or try to correct that with the setup or the wax up, and you throw it in their mouth and you're like, okay, say 55, say 66, Their tongue isn't instantly gonna react to that. They need at least a week or so to really adapt. So let them try it out. If they had a lot of speech issues and you're trying to correct that with a new setup, let them try it out. Let them test it. Take it home. They have 30 days, and you can print another one after 30 days. You can make your changes, send them home again. We're going to get so much closer to one try-in. We're going to have less remakes. We're going to have higher patient satisfaction because we've taken the time to do a test drive, essentially. So once we print it, we're now on to the second appointment. This is our try-in. So your practitioner can mark it. They can draw on it. You can see here. They can take a new bite. They can take a new wash. You can't really see here, but it's been cut. So the bite was really heavy in the posterior, and they wanted to take a more accurate bite, so they just planed it down, which they can totally do, take a new bite, and you don't actually have to redesign this. You can put this back into your 3Shape software with this new information, keep your old design, and align all this information. There's specific workflows for that, so you don't have to redesign. What happens in analog when you have to move the midline? You have to move every single tooth. You have to verify that you didn't change the plane, you didn't change the buccal alignment, you didn't change the angle. You have to verify all these things. You have to check all your contacts, and then you have to re-wax the whole thing and send it back. For this, you go on your computer, and you go click, and you move the midline. And that's it. Print out a new one, another try-in. It's so time efficient to make these changes. You're not redesigning the whole case. You have all your data. You're just moving the midline and printing out a new one. So at this try-in, this also comes back to dentist education. The try-in material, because it's a lower cost, is never going to match any final denture you make. If that's milled, printed, whatever, that A1 is never going to look like a Flexera A1. It's never going to look like a PMMA A1 from this company. They're all going to be different. So you have to tell your dentist, because it's going to change. The way they do the try-in is going to change a little bit, because they're used to having the teeth in the try-in, and that's what goes to the final. So they're used to having that discussion with the patient. They have to change their discussion a little bit and have an actual shade. So this one up here, I actually made this because not too many companies have milled shade tabs or printed shade tabs. So the discs that we were using at the time, I cut a tooth out of every single one. I ripped off an old shade guide and put a tooth on every one and made my own. And then this one here, just in Argen, Canada, we've provided a couple shade tabs on a little keychain for some of our customers, just so they can see what the final result is going to look like and have that discussion with their patients. All right, and we're going to mill it. Like I said, moving forward, we're going to talk about milling because we kind of really went over the workflows for printing. So once we have finalized it, we're going to mill it. So when you're milling, this is how it comes out. So on this before side, this is like literally fresh out of the mill. All I did was cut it out of the puck, fresh out. And this is a realistic case. It's not beautiful. It's not highly characterized. It's just a real normal case that we do on an everyday basis. This one on the bottom, I didn't do any extra work to it. So typically I would go in and work the teeth and try to make them look a little more like a carded tooth. This is nothing. This is just pumiced and high shined, straight out the mill. So this is about 5 minutes of work. And you can see that is super simple to get those out. So the way that your labor needs to work on this, put the puck in the mill, hit go, take it out of the puck, polish it. There's not the same post-processing steps. Not that printing is any worse or bad than milling, but you need to understand from a labor standpoint what that looks like and where your staff is most efficient. And then this is fully milled teeth, milled base. Not the greatest photo, but it's highly characterized, so spent a lot more time around the teeth. This is old. This is about 3 years ago. I was using the GC Grady. I don't really use that anymore, but there are options out there for characterizing your case. You can really make them look like a carded tooth or like a nice natural tooth. It's not impossible. It's just spending a little bit more time finishing on the teeth and less time on the base. Whereas in analog, you do not touch the teeth and you only focus on the base. So just changing your thinking a little bit. It's okay to touch the teeth. It's okay to make them look nicer. You can grind on them. Nothing bad's gonna happen, I promise. So you can get really good aesthetic results from a milled denture. And this example is actually a much more recent milled denture. So this one specifically, this picture is from a customer who has a Roland 53 DC, like the new Rolands for PMMA. And my point is with these new milling strategies, so the software being used, these new strategies, look how this came out of the mill. Like, this shocked me. This is shiny. You basically just have to high shine this. There's hardly any work to do. So this specific case, he's using a carded tooth workflow. So he's going to glue in all those carded teeth into those sockets. But like this coming right out of the mill, your labor is so minimal after. You basically just have to high shine it. You can train an assistant to do that. You don't need to use your skilled labor to do that. They can be focused on designing and patient planning. So really, really quick, 3 appointments. We did a wash impression, a printed try-in, and a final insert. So this is how you can work with your dentist to cut down their chair time, cut down your lab time. So what does that look like from a time perspective? White is hands-on. Gray is processing. So this is also assuming that we're scanning the impressions, because for your preliminary impression, your dentist could be scanning that for you. So then you'd have even less time. Also, when we get into digital, I wanted to maximize our time. We're a little bit new, we're not as efficient. So for analog, we're super efficient, and that was kind of my timeline. For this, I'm being generous with time. I put 20 minutes to scan a wash impression, upper, lower bite. It does not take that long, but I'm gonna be generous, just so we can see how much time can we actually make this work. Design a try-in, 50 minutes. You can cut that way down. You can get that to 30, 35 minutes, but 50 minutes, we're being generous, we don't know how to click the buttons, we're having errors. 50 minutes. Nest it for printing. So every time you design something, you have to bring it into your printer and tell it how you want it to nest. A lot of these higher-end medical-grade printers, it's so easy to use. You just click add sprues and adds the sprues and it's done. All the settings are dialed in, everything. There's no tinkering, no playing. So when you're looking at purchasing a printer, you also need to know kind of how the nesting software, like how long is it going to take me to nest this? Is it complicated? Where is my labor going to be? Is it easy or difficult? So this is super easy on a Sega, 10 minutes, less than that, literally 2 minutes. And then we're going to print it. So printing is determined, the time of your print is determined by your Z-axis, your Z-axis. We're not in Canada. It's by your Z-axis, so it doesn't matter how much mass or volume you have, it's how high the object is, because it's printing by layer. So however tall your object is, that's how long it's going to print. So I assumed, for this example, that we're printing it completely vertically on a pretty slow print, and it's about 120 minutes. Honestly, if you're in a rush, you can print those try-ins pretty flat and get them done in 30 minutes on a Sega. It's not something that will consistently take that much time, but I put the max time just so we can see what that looks like. So post-process, we talked about that. So 10 minutes hands-on, 65 minutes, all the post-processing steps, letting it dry, all of that. I did not include the 60 minutes for soaking it in wash, because you could do that before the patient comes in. So that's just your standard post-process. They love it. Let's redesign it for finish. Let's walk through our design, tweak anything we need to tweak, see if we need to change anything. 20 minutes for that. Nesting for milling, same thing. It doesn't really take this long, but sometimes if you're new to camming, some of the buttons can be confusing depending on your camming software. So I put 20 minutes. It can be a lot less than that. And then you're going to mill it. And it's like way off screen. It's very long. This, again, I went for the maximum time. So I put 360. So when you're milling a denture, one case, you have to mill an upper base, a lower base, and your teeth. That's 3 pucks. And so you have to account for the full time of that. And that's why initially industry was saying printing's faster, because I can print something way faster. Yes, you can, but there's more post-processing steps. So as a whole, time-wise, I'd say they're almost close to comparable. So I put the maximum mill time. You can get that mill time with the software very, very low. But in order to do that, we're pushing our mills to the absolute limit. And you don't necessarily want to do that every day, all the time for all of your dentures. So yes, it's possible to lower that very, very low, but you're going to be wearing through your mill a lot faster. Then you're going to remove it, trim it, polish it. So 15 minutes, they come out shiny. What does that look like? So hands-on, we're looking at about 2.5 hours, and then 9 hours for processing. So let's really compare the two. So on an analog workflow, I said 4.8, that's a typo, but basically 5 hours for hands-on time, and about 2 hours, 2.5 hours for processing time. for a 3-appointment workflow, we've cut our hands-down time in half, and our processing time is a lot more. So when I started my journey into digital dentures, maybe 7, 8 years ago when I started investigating this, and they had the Avident or Almond Gerbach said you can mill a wax denture base, I was a little cocky. I was very good at my job, and I was like, I can physically make a denture way faster than any of these machines can. I can set and wax and process like no tomorrow, and I can get this done way faster. I had to think, change the way I was thinking about this. It's not about how fast I can get that product done. It's about how valuable is my time, the use of my time. Where is it being used? The equipment can run overnight. The equipment can run through a lunch break. The equipment can run over the weekend. My time is more valuable than that. I don't want to be there till 11 at night anymore. I'm sick of it. I don't want to come in on a Saturday to process my dentures. I don't want to work through my lunch breaks and munch on a monomer sandwich while I'm processing my dentures. I want to actually have a life. So we can put that time onto our equipment. And so maybe your full output of a denture takes 1 day longer. But if you go to your dentist and you say, I can cut your appointments from 6, 7 to 3 or 4, I just need 1 extra day to manufacture, they won't care, okay? You just have to structure the way you output your cases a little bit differently. You can have a better quality product with time saved, essentially. So change your way of thinking. So let's go through really quick. I'm not going to break it down quite as much for a couple options for a 4-appointment workflow, because not everybody has a denture that they can use and take a wash impression. And so option 1 for a 4-appointment workflow. If they don't have a denture, they have no teeth. I know this impression has some teeth, but pretend there's no teeth. And they come to you and they want to get started. You take a wash impression, then you do final impressions, printed, tried, and a final insert. So if you look at that final impression, that little orange thing, that's what's called a nathometer. That's an Ivoclar's version of a digital pin tracer. So if you have clients, or if you as a denturist really like using a pin tracer, there's a digital workflow specifically for that. So I'm just going to go through really quick these first 2 steps, because we already covered the last step. So what does that look like? So the first appointment, your practitioners are going to take preliminary impressions, and you're going to scan in a preliminary bite. You cannot go to final with this. This is a preliminary bite. It's in a triple tray. In no way is this accurate, but you're getting a general, space for your models to articulate. So you need something general for your models to articulate. So up on the left there, you can see you're aligning 2 soft tissue impressions. So in no way is this an accurate bite, but it's giving us a starting point. So once you aligned everything in here, it's going to make some models for us, and we'll see at the end here. And because we used a triple tray, and this was one of the first ones we did in the clinic, and I was working with the dentures, we didn't really know how to use a triple tray to take a bite. So this case is super overclosed. So if I was to just go right to finish and just crank that pin open, I don't think this would be accurate at all. But I can actually make what's called a nathometer, and I can do a pin trace. So, and this is something that your clients value or that you value. There's a workflow for this. It's here. And essentially, you get these little metal things, just like your normal pin tracer. You have to buy their version, because it doesn't actually fit with your old ones, and you can do that. So I put these other ones up here to show you can actually clip them onto a try-in or a partial try-in. So if you only want to set your 6 anterior and leave your posteriors empty, so you can clip this on, you can totally do that too. And this is what it would look like when it comes back to the lab. So they're going to take their final impressions and a bite and everything. And if your clinicians want to learn how to do this and use this tool, Ivoclar actually has a 4-video workflow. It's on their website. Just go check it out. And it's clinically based. So you'll look on the clinician side and see how to use this tool. My point is there's workflows where you can still integrate the same amount of quality that you had with analog. So after you've done those 2 appointments, again, you would scan in that final impression, that thing that they give you all back in one. You do a printed try-in and a final insert. Option 2, I would argue this is probably The most common option, my favorite option, I think the most efficient way to go ahead with this. So the first appointment, you're actually just going to scan a copy denture. So you're not going to do a wash impression, you're just going to take the denture and scan it. And then at the next appointment, you would print that copy denture and do a wash impression in there. The reason why, a couple of reasons. One, you can adjust that flange, you can grind out the undercuts, you can make more space, even in the software, you could cut things, add things, change things to make a custom tray for yourself. And also, when they come back for their final impressions, you don't have to take it in their current denture, they don't have to wait for you. You can take their impressions, send them home. They already have a denture in their mouth, right? So impressions, home, to the lab. So I really like this workflow. So same thing, you would scan in their finals, do a printed try-in, use all of your tools to do a printed try-in, and then insert your final denture. So let's say we're doing the nathometer. This is the last workflow we're really going to go through. Let's say we're doing the nathometer, what that looks like. So there's a lot more steps, because there's more steps involved. So you're going to scan the prelims. You're going to design a custom tray or a nathometer. Honestly, both workflows, custom tray, nathometer, 5 minutes flat. Like, the software is so easy. I put 20 because we don't know what we're doing. We're newbies, that's fine. Nested for printing. Print it, post-process, just like before. We're going to scan the finals, just like before. Everything, all of these pieces are exactly the same as before. There's just a little bit more of them. And I'm going to mill it, remove it, trim it, polish it, all the same as before. So total about 3.4 hours hands-on time, 12 hours processing time. The reason why is because we had to print multiple things, so your print time and your print processing time goes up a little bit. Again, that can be cut down depending on printer, depending on batch printing. This is just one example. So what does that really look like comparatively? So we kind of went through these two. So it's a little bit more, obviously, than a 3-appointment workflow, but it's still faster than analog, hands-on wise. Obviously, processing time is way more. That's because we had to print multiple items. And so it's going to change your full overall workflow. But that doesn't mean your final product's going to be way longer. It just means the steps in between could potentially take a little bit longer. So let's actually analyze this. So one case, so an upper and a lower. You are spending, so for analog, which is in white, you're spending about 5 hours of your hands-on time for one denture case. If we switch that to a 3-appointment workflow, you're spending about 2.5 hours, almost cut in half. If we make 4-appointment workflows, because not everybody can do that 3-appointment workflow, we can cut that down to 3.3 hours. So let's extrapolate. So let's say in 1 month, we can do 15 cases. This is now how many days, this is not hours, this is how many days we're spending working on 15 cases. So for analog, you're spending 9.2 days making 15 cases, or 4.5 days, or 6.1 days. Let's extrapolate a little bit further. What about in a year? So if you do 15 cases in 1 month, how much time in a year are you spending making 180 cases? You're spending 92 days making 180 cases, or 45 days, or 60 days. How much time are we actually saving? So if we switched 180 cases to a 4-appointment workflow, we're saving 46 days of work, of labor time. So what does that mean? Is that, I don't know how many 46 days, like 6 weeks or something? I think like 8 weeks. You can have, 8 weeks of vacation. But more realistically, you can maybe keep all the staff that you still have and take Fridays off, or make it a shift so that some work Mondays off, Fridays off. So all of your staff gets to have a 4-day week at the same amount of pay, at the same quality. We want quality of life for our staff. That's how we retain people. So instead of just seeing how I can benefit, I want my whole team to benefit. We're all working our asses off. Let's really benefit together, right? So, or we can really up our volume. We can really pump out way more cases if we're saving this much time. Like, this is ridiculous. Part of this, though, is dentist education and working as a team. You can't just start this and expect this to work overnight. It's not. It's going to be hard to transition, but it will eventually work for you. So The last two here are a little bit quick, but we'll go through them. So let's talk about maximizing our efficiency. So one, you're going to have less try-ins. We're going to use all of our design tools to make sure we're reducing our try-ins. We're going to use copy dentures, we're going to use original data scans, patient photos, 3D face scans, all of these to reduce our try-ins. So we're saving our time, we're saving chair time. Quick adjustments and also less adjustments. So it's really easy to scan in a new bite. It's really easy to move the midline. It's really easy to change the tooth shape, scan a new wash, all these things. This is quick. Can you imagine scanning a new wash impression analog? I mean, you probably don't have to imagine you've done it. That is such a process just to pour a new impression, remount it, make sure everything's fitting properly. It's not fun. In this, you just scan it in and you could do another try-in, like no problem. You have fewer adjustments. So because our bite is improved, the way it fits in the patient's mouth is going to improve. A lot of times the sore spots are not actually due to the impression, they're not actually due to the tissue side, they're due to an incorrect bite. So your patient's biting down and it's wiggling around or moving up and down, it's going to make a sore spot. So if you have a way more accurate bite, it's being milled out exactly how you designed, you can reduce the adjustments afterwards. Dentists don't typically charge for adjustments. It's just a waste of time, a waste of money. So if you can cut their adjustments down, guess who they're going to come back for business? They're going to come back to you because they know that your product is a lot better. Improved fitting surface. So when you cook a denture, there is so much room for human error. When you're investing, when you're boiling out, you know how many models I've broken boiling out and I try to glue all the little pieces back together? Like, that's not super accurate. When you're cooking the actual denture and you have that chemical change from your liquid and powder into your solid denture, there's going to be a change in dimension. There's no way, no matter how hard you try, that you're going to have an extremely accurate denture. With this, we're milling it out of a puck. Nothing's changing. We're cutting it out of something that's already been cured. So your tissue fitting surface is going to be better than what you can do analog. You have forever data. This is so valuable. Always, always, always scan a copy denture. Every single patient that comes into your dentist's office, scan a copy denture. Because what happens with dentures, they come out of the mouth, so they are more likely to break. So their dog eats it, they throw it off a cruise ship, I don't know, something crazy happens. You have a copy of that denture. This is two things. One, retention. It's patient retention, it's dentist retention. They are going to come back to you because you have the data. Two, a look into the future. 5 years from now, when all of your patients are coming back for their new denture, you can cut this workflow down to 1 appointment or 2 appointments because they're going to call the dentist and be like, hey, I need a new denture. And you can go, I will print you a copy of your previous denture for that appointment. Patient comes in, they have a full exact copy of their denture from 5 years ago. It needs to still be evaluated. Maybe they need a wash impression. Maybe they need some changes. But you are already 3 steps ahead. You're at the final impression. You can go to finals at the next step. So 5 years from now, this data is invaluable. And if you're looking to sell your clinic or sell your lab, you're not only selling a file of dentists and patients, you're selling the data. So you have so much valuable information, and that adds so much value to your clinic or to your lab. So a couple other things that we don't really have time to talk about today, but that are totally possible digitally, where you're going to save a lot of time, is immediate dentures, the bane of my existence. Doing immediate dentures digitally, oh my God. Life-saving, life-changing. You have so many more tools. You always know where the natural teeth are. You always have your reference point. You can do a 2D cross-section. Like, this isn't even full-on crazy implant planning that you're going to see. This is just planning for an immediate denture. You have all the basic tools available to you. You don't need to know crazy implant planning. You can actually plan this pretty well just with your basic software. Partials and flippers, again, I won't get too much into this, but these are fast, and they are way more accurate when you're using an intraoral scanner. These just clip right in. You can pump them out really, really quick. Splints are huge. When I was working in the lab, we had a splint department of 4 full-time people just making splints all day long. And I don't know how they did it. They loved their job. I couldn't do that. But now, what you can do, and like don't lay off your valuable staff, you can put them into other valuable positions. They can now be into manufacturing. They can now be into designing. And maybe you have one full-time person doing all of your splints and using those other people in more valuable areas. And then, of course, implant cases. This is my favorite. I love implant cases. We could talk about this all day. We don't really have time today, but if you see me around, I will chat with you till midnight. Let's talk about implant cases. But you can get a lot more efficiency out of your implant cases too, and using that data is very valuable. So then very, very last is your equipment options. Now we can decide what equipment we want to buy. Now we can decide what we value and what we can determine has the most value for us. So obviously you need a scanner, and like the ones I have on here is just one option. You don't need to buy this specific option. There's so many options. You need to determine your value. So if you just want to get started and all you want to do is like dip your little toe in, all you need is a scanner. You can outsource the designing, you can outsource the printing, you can outsource the milling. You can't outsource the scanning because then it's no longer your case. So you need to at least get a scanner, and you can start acquiring data, and you can start a little bit into dental, digital dental. So that's an intraoral scanner, and this is a bench scanner. The next step, if you want to take this into your own hands, would be a design software. So same thing, you can outsource the printing, you can outsource the milling, but now the design is in your control. So you can use 3Shape, you can use ExoCAD, whatever you want to use for this, but that would be the next thing that you need to purchase. And then you need a printer. And now, at this point, once we understand which resins we want to use, what the process is for printing, where the value is, maybe you don't want to mill all of your dentures, maybe you want to print all of your immediates. Also, if you want to get into this workflow, you still need a printer for your try-ins. But maybe you don't need the fanciest printer for your try-ins. Maybe you can go with something a little bit simpler, right? So now that we understand our workflows, we can determine the best options for us. With a printer, you're not just getting the printer. You also have to get your wash station. You have to get a light cure unit that's approved. And I would highly, highly suggest some additional ventilation. This is, and again, not something that was explained to me when I started. This is a volatile material. Uncured resin is not healthy to be breathing in. I was literally just dunking my hands in there. Like, you should not be doing that. You should be wearing gloves, you should be wearing a mask, and it should be well ventilated. And if you don't have the ventilation, there are things that you can purchase. You can purchase like an overhead box that sits on the counter. You can get a ductless fume hood, so you don't need to vent it outside. It's all built in. You just plug it, mount it on the wall, plug it in, and you're just providing a little bit more safety for your staff. We're a team, right? We want to value the safety of our staff. It's really hard to hire more people, okay? You don't want them to get sick or get an allergy and have to leave the dental industry. We want to retain our staff, so let's make a healthy, safe environment. So when you're purchasing a printer, you have to understand all the additional equipment that comes along with that. And then if you want to, you can get into a mill. So this is one example. This is the Roland. You don't have to get this mill. But when you look into a mill, you want something that is robust enough to mill PMMA over and over and over again. So sometimes they might say, yeah, you can mill PMMA, but what they're thinking as a salesperson is you can mill some zirconia, you can mill some wax, you can mill some PMMA. You need to ask, I'm only milling PMMA, and that's it, forever. How robust is this mill to mill only PMMA? How many, is my spindle going to break in a month? I need something that's really powerful enough to handle milling PMMA forever. So we kind of went through all the options today. This is kind of the full workflow. And just to close it out, I have made this little workflow diagram. I made this a couple years ago, and people really, really liked it. So you can scan it here, you can get a copy of it, or you can email me or come talk to me after. I like to share this with my dentist. I like to share this with my labs, just so I have a basic understanding of some of the workflows that we went through today with pictures and arrows, and makes it simple and basic. And then just a couple of thank yous, really, really quick. Oops, go back. Super thank you to Argen. I'm from Argen, Canada, and so coming down here, getting to spend time with you, this is awesome. Thank you to the team for setting all this up. Amazing. Tanya Little for giving me her slides. My really good friend Hannah Sung provided a lot of the clinical photos that you saw today, because I don't work in the clinic anymore. I work full-time with Argen, so I asked her for all of her clinical photos, and she's a student, so she gave me some pictures. So thank you to those. And then lastly, if you want to watch this later, this is being recorded. You can actually find the video here on YouTube. It won't be posted for a couple of days, but eventually it'll be there. And then this is just a little bit about myself. I know I talked all day, but I don't only like dentures. I'm from Canada. I really like fishing. I like hockey. Go Oilers. I like quilting. I'm kind of an old lady, so I have a little crew of old lady friends, and we all go quilting on the weekend. I have a little chihuahua. I will happily talk about any of these things. Please come talk to me. It can be only dentures, but if you like fishing, let's talk fish. So thank you guys so much. Does anybody have any questions? I'm sure you have questions. I will be here all day today and just in the morning tomorrow. Please come find me, but thank you guys so much for being here.